Number 7 says, which is the initial value that shrinks an exponential growth function by 50%? So it says, what is the initial value that shrinks an exponential function? So it says initial value that shrinks exponential growth function by half. So it says here I have an exponential function. So let's say, let me draw this out. So this here, exponential growth function. This here I'll say it is y equals 2 to the power of x. This here is my standard exponential growth function. So it says here, what is the initial value that can shrink an exponential growth by 50%? So let's say that I know here this is at 1, right? Let's say, what if y here equals, let's say let x here equals 3. So let's solve for this here. 2 to the power of 3 here is 8, right? So y would equal 8, which means 3, 8 is a point, right? So let me say this point here is 3, and this here is 8, right? Is 8. Oh, sorry, it's kind of messy here. This here is 3. I have the 0.38, right? I have the 0.38 in my function here. So it says here, initial value to shrink the initial growth function by half. So I want to actually cut this value by half. So let's say if y equals 4. So if I'm shrinking it by half, I'm taking the y value and I'm multiplying by half to get 4, right? So at 4, what is the initial value that shrinks an exponential growth function by 50%? So I have to solve for what is kind of this, where would y equal 4 be here? So let's say, so in this case, I'm solving for my x value now. So I have y equals 2 to the power of x. If y is now 4 to the power of x, I know that x here equals 2, right? 2 squared is 4, right? So again, this here, my new value would be at 2 instead of at 3. So in this case, I am going to have to, in this case, I prove that the growth function shrinks exponentially by half if I simply halved my y value. So I'm simply multiplying it by 1/2. So D here is true. So A is false because if I multiplied by a quarter, I would get the value of 2 and not 4. If I have the base function of 2, it will actually double in size, and you get 16 instead of 4. I get negative half, you actually get a reflection, and you start getting a decreasing function, right? If I plotted something like this, y equals negative half to the power of x, you get something. Actually, let me just do it on Desmos to save time here. Negative half to the power of x here. Oh, sorry. Let me just do negative 0.5 to the power of x. Does that help? Yeah. As you can see, your exponential function is now flipped, and it's a decreasing function, right? So if I had a function that was decreasing like this here, it would actually flip and do something like that. So you get this function here. That's this guy over here. So you get definitely not shrinking because this is now heading towards 0. So the logical answer here would be D, and just multiply by half. Value C cannot be negative. B is false, which is true because it would actually increase the growth, and C here is half, right? So if you have half of A here is equal to 50%. So they actually solved for, they actually did the similar algebra like I did here, but I assumed a 0.38 where they kind of assumed a point which is 100%. So this here is great. Solution and analysis. Solution is correct.